sometimes it's fun. And we are going to talk to you. So Nina is going to talk to you, and myself, I'm Matthieu. So a quick word on what we are going to talk to you about today is share of experience on an ongoing project. The project is still running, but still we drafted something that is we found quite interesting, and we already want to share some results and some feedback to maybe have a discussion later to see if you agree or not with the approach. So our client is someone who is running a big insurance company, and he also has a part who is doing banking. And this client is used to do a lot of marketing campaigns to sell their product to their client. And they ask us the general question, now we have big data, now we have a nice Hadoop cluster and so on. Can you do better with big data than what we have been doing as usual? So, okay, we'll see. And just a little word on the use case on itself. The campaign that was going to be challenged with the big data approach was this following: as presented, the client is mostly an insurance company, so it has more than 5 million clients in his insurance part, and he also running a bank, and there is less than 1 million clients in this part. So his goal is to say, okay, I have a lot of clients in the insurance part. Can we make a campaign that speaks to my insurance people and try to push them to the banking part? And to do so, we can use multiple display channels, multiple marketing tools to try to speak to those guys, to try to convince them to join the bank. So we can use displays with the use of a DMP or the tagging of their own site to push some ad campaigns, or we can reach them through emailing. Cool email you receive regularly from them, and you can also direct call them with the use of agent and so on. So quick words on the state of the art of their data and where we are coming from. They have a nice Hadoop cluster. Okay, they've separated the two data sets from the banking side and the insurance side in two separated tenants. Something quite usual to respect the legal constraints, because if you have multiple practice, you are not allowed to merge all your activity into one single tenant. So there's two parts are quite isolated. So it was quite a constraint in the beginning. So they presented like that. So we have a lot of client activity data, all the classical customer relationship management data, the CRM, and all their activity. When do they contact me? How often do they call me, and so on? What was the latest accident they had, and so on and so on. So as good consultant, we said, of course, we can do better with big data than you can do, but okay, as a good consultant, we don't really know what we are going to do before selling the project, but we say, sure, we can. We always can improve things. So we come back and say, okay, what can we do better than what they have been doing for so long? We looked at what they usually do in the classical scoring campaign. They do something like that, like a lot of people do when they do a classical marketing campaign. Is they do an attendance score to see who is going to be likely to buy the product or not. So what they do is, okay, we train a predictive model on the client base, on already people that have been already bought the product, to try to understand why those people have bought the things, and so maybe to find other people that still haven't bought the project but share the same characteristic. So they fit a predictive model like that, and then they apply the model to the whole client database, score the best people that have been targeted by the model, and send a message to them, because you say, okay, the model told us that you are going to be likely to buy our products. So okay, this is and from that we try to find the limitations of this approach. What are the problems of this classical approach? We found two major limitations of the approach that usually makes those kind of approach good, but that we can still improve. The first thing is that there is a lack of personalization. In big data, we like to say that we have so much data that we can know exactly who is my consumer, what do they like, and try to personalize a little bit the message we are going to send to them. So one problem is that they're sending the same message to the top score of people. Okay, why not? And another limitation of this approach is that they also scoop with this approach the natural noise, which means that when you push some product to push some message to some people, you are spending some money to contact them. But among those people that you've been targeted, some people would have buy your project anyway, because the model will find some things that are based on the population, and not based only by the project, the message that you've been pushed, not by influenced by the message. They would have bought the project anyway, so it might not have been interesting to bother them with an email or something like that. So to tackle the first problem, okay, we have one message to shoot to a group of people. So maybe we will send multiple messages. Yeah, good insight here. So here the idea is, okay, instead of sending one single message, we'll try to do a little bit of personalization in your campaign with the hypothesis that for some people you are going to contact, some of them will like to hear some kind of message, some kind of arguments, some will like to hear other arguments, and we'll push the right message to the right person so we can have a different differentiation on the target, on the message we are pushing, so that people will come, will find things that are more, they like more. So here's now to tackle this. Okay, now we have complexed a little bit our problem. We have to find a way to dispatch the right message to the good person. So to do so, there is a classical approach in machine learning and in data science, is that we are going to do what we call test and learn. Is that in large line, it's saying, okay, it's okay if at first you are quite dumb in your prediction. You'll do some stupid things, but you are going to learn quite fast and improve regularly with a small incremental thing. So you do stupid things at the beginning, but the model is going to improve as you are trying to push the message, as you are getting back the results, and try to find a convergence on some rules. So here the idea of test and learn is that, okay, we are going to push almost randomly at first the different message on some small part of the population, and try to find, as we are studying the results, the feedbacks, if we find better and better rules to make those kind of conclusions. So test and learn, yes. So how did we do that exactly with their part? Is that, as told, there was a data lake, everything stored in Hadoop, in HDFS, so we have all the data from the insurance part. And by the way, we get rid of the banking part because we didn't really need, because we were targeting the insurance people, so no need of worrying about legal issues. We are just going to work on the insurance data, so it's simple our life. So we have a Hadoop cluster here. We have the classical pig hive technology and some Spark that is going around in this kind of cluster. And the upper part is all the people that have been eagerly waited to be contacted by mails and spams and so on. Not spams, mails and nice campaigns. So first thing to do is, okay, at day 0, I'll try to sample a random sampling of our client database, a small percentage of our client database. And okay, I say this client will receive randomly this message, and so on and so on. And every day, sorry, it's a bit shrinked, but what it says here is that every day I'm going to send to my people who are going to run the campaign a set of rules to say, okay, this guy is going to receive this message, this guy is going to be contacted by this guy with this kind of message, and so on. So okay, D0. And then we contact those people, okay, we push the message, fine. And we get the feedbacks every day. We dump back to the data lake, to the Hadoop cluster, all the response that we have observed for the day. To say, okay, who among the people that have been contacted, who clicked on this message, who answered positively to this message, who didn't like it, and so on and so on. So once we get it back to the Hadoop cluster, we have to redo some reconciliation between the cookies ID and the client database. But we can join back every information with all the data we have in our data lake to build a feature matrix, to build a training data set that we are going to try to fit a model with Spark and Spark ML. Just a quick word, we used for the data cleaning, data preparation, Pig and Hive because it was more robust and also because it was a little bit safer for preserving the resource for the Spark cluster. A lot of people were using the Spark at the same time, so it was fine to use Hive and Pig that they were quite untouched and quite more solid to do this heavy workload. But the machine learning part, we did it with Spark ML. And then we do a loop like that. At day n+1, once we change our matrix and we score the whole client database, we used these results to push new rules for the day after to say, okay, now I have a first prediction based on what I've observed yesterday. I can do a bit smarter prediction on who is going to like this message or not, and therefore I can be a bit more efficient on the part. Taking a lot of time. I'm going to hurry. Okay, so this is the general approach on how we're going to find the best message to push to the good person. We'll do loops like that, and once we observe that we have a stabilization in click rate ratio, like people we are going to tend to click so on, we will know that the right message have been targeted to the right kind of people, and then we can push to the whole client database the generalization we have been doing on smaller part and some toy examples. Okay, so we now have a strategy to push the right message to the right person. But there's still another problem, is how to get rid of the natural noise. How can we make sure that when we push a message to someone, it's going to be positively contacted by this message and not being annoyed by receiving this and say, okay, you send me an email and so on, I don't want to contact you anymore. So to try to get rid of that, Nina is going to talk to you a little bit on how we did that with some type of machine learning approaches. Up to you, Nina.
So we would like to get rid of this noise. So we use another approach, which is called Uplift models. So quickly, the main idea of this modeling is to describe the message effect on the target, on the buy of the product. So there are 4 groups of customers. We don't want to call 3 of them. They are do not disturb customers, the lost causes, the sure things that are already convinced to buy the product, and we would like to target the persuadables, the customers where the call has a positive impact on them. So to measure this impact, we have to dissociate 2 groups. So the first one is the treatment group, the one who received the call or the email, and the other one is the control group, which corresponds to the placebo, who hasn't been called. So there are different possible implementations. We use the first one, and if you want to find information for the 2 others, you can find it in the literature. So independent models was the choice we made. I'll explain later why we made this choice. So in real life, we have to build many models, 1 model per canal and per message. And every model are independent. And we consider 2 classical machine learning methods, which was random forest and logistic regression. So independent model was our choice because it's easy to code in every technology, And it corresponds to make the difference between two probabilities. So the first one is the probability of purchase after the campaign, and the other one is the natural conversion. So there is a main difficulty with this approach. It's because there is a predicted uplift by customer, but we don't know in reality if the call or the email has an impact to the choice of the customer. So there are no real uplift by customer. So no individual targets. So how can we measure this performance? The solution is to sort customers by their uplift score in decreasing order, and to make groups. So we focused on decile of customers, and then we calculate the difference between conversion rate of the treated group and the control one. So to illustrate this, here's an appetence model. There are the groups sorted by this score, the blue one, and there is in red the uplift, which is the difference between the conversion rate with treatment and the conversion rate without treatment. And as you can see, groups with highest conversion score has not necessarily been scored with the highest uplift. So we would like to focus on this group. So we focused on this kind of model, which is uplift model. Here is what we would like to obtain. This is a graph sorted by the uplift score, the predictive uplift score. And in red, you have the observed uplift. And in the perfect uplift model, it's it's a decreasing order. So in our use case, what we've done is to use two messages for this proof of concept. And the DMP side is ongoing today, but we have built two waves for the call and the emailing campaigns. And we have built uplift model. So here's the example of the mail canal after the first wave. So there were two messages. For the first one, you can see that the message is really efficient because people in the left are the highest scored by the model, and you can see that the real uplift is really good. But you have to know that some people hate this message. So people on the right, who have lower score, we don't want to call them. And on the other side, you have the second message, which was come with simple real life. And you can see that there is a small percentage who likes this message, but the main information is the rate of the plots. You can see that for these people, you shouldn't call them because the call or the email has a negative influence on them. So after the build of these two models, you just have to take the best score between the two and to send the message, the uplift model consider.
It's been best scored, yes. Just to conclude this little presentation and to reserve some time for the Q&A, some quick feedbacks and pitfalls that we've been encountering. The first thing to say is that on paper, the approach to do this test and learn is quite simple because you say, okay, you just have to share some files between for example, the DMP part and the data lake, and then we'll be fine with the learning. But some business organization and IT organization are sometimes quite heavy to manipulate that. Plus, there is some political choice to do that. So they wanted to do a lot of proof of concept before involving more resource to it. So we spend more time to try to prove the approach before trying to push all the efforts to this pipelining. So to gain some time, Spark is good. Okay, we have a Spark in our cluster, but to accelerate a little bit our development for the training, to find a good model and so on, we did the first couple of rounds on scikit-learn, and then for the more industrialized way, we then recode these things on Spark when we knew a little bit more what we wanted to do, because we gained some time like that. And one quick word on the results. It's even we were quite excited on showing on having those kind of results, because we observed that it was quite efficient to get some new insights on your marketing campaigns. It's some kind of results they never saw. They never control who liked or don't like their message. And you can know that with this approach, you can control a little bit better what people want to hear or doesn't want to hear. So here we can say, okay, people, of course, tends to be more reactive to message that will earn them money, but some people would like also to hear that they are going to be still better a campaign with the same product. And of course, you now have a clear idea on who you should definitely not contact with those, because with those guys, if you push emails to them, you are going to lose them, even though they would have come to your project without being challenged by you. So this concludes our little presentation on this use case. And if you have questions, we'll be glad to answer them. Yes?
When measuring the uplift, how do you verify that the uplift, the effect is not caused by the bias, potential bias in your control group, in your test group, or not? So, I can rephrase the question as, how do you partition your user base into control and test group?
It's from the initial database of the whole client that has been eligible to the project. We just make sure that there is some people that will never send email. So we really separate the two groups. Some people we observe them like that with, okay, are they buying the product without having to hear the message? And the other group, are they buying the product if once they've been contacted? So we really measure the two different ratios like that, and after that we can measure the delta to sort them by Uplift score. So yeah, it's one difficulty is that you have to make sure that your placebo group is really left untouched, because sometimes if you make a bad join or bad something like that, you will contact people that you shouldn't have contact and mess the whole result. So you have to be really good on splitting those kind of groups.
Thank you, Matthieu and Nina. We have time for one last question, and the rest of them you can take it offline. Do you need a mic?
Yes. Yes, actually, it was something that makes sense. Mathematically speaking, we want to group as big as possible, that will still left as room as possible for doing a lot of iteration, and plus some political constraints on what the budget I have to burn on random use. So we aimed at something like 100,000 people for the first campaign, something like that. 305,000, so in order of magnitude, something like that. Okay, right. So if you have any question, we will be glad to talk to you offline.
Thank you so much.